Hi everyone. In this video, we are going to discuss about electrical system, how to model an electrical system with an example. The model of electrical system can be obtained by using resistor, capacitor and inductor. This particular table represents the voltage current relationship in resistor, inductor and capacitor. If you take the resistor, the current flowing through which is I of t, because of that there is an voltage drop. The voltage across the resistor V of t equal to R into I of t using Ohm's law. I of t is nothing but V of t by R. This is an inductor. The voltage across the inductor is L into di by dt. Current through the inductor is 1 by L integral V dt. And this is a capacitor. It stores an electrical energy. Voltage across the capacitor. This is a capacitor. It stores an electrical energy in the form of 1 by C integral I dt. The current through the element is C into dV by dt. For modeling electrical system, the electrical network or an equivalent circuit is formed by using RLC component along with voltage and current sources. And the differential equations governing this electrical system can be formed by writing Kirchhoff's current law by choosing various nodes in the circuit, or we can use a KVL by choosing various closed paths in the network, and we have to take the transfer function. How to take the transfer function of this network? We know that the Laplace transform of output by Laplace transform of input. And let's see the problem. Objective is to obtain the transfer function of the given electrical network. If you see here, the input is E of t, output is V2 of t. The objective is V2 of S, that is Laplace transform of output, it is V2 of S divided by E of S. That is what we have to compute. Let's see how to do that. This is the given question. First, we have to go for converting this voltage source in series with the resistor into a current source. We know that source transformation we are applying. We have an voltage source in series with resistor. We are going to convert that into a current source in parallel with resistor. Here it is V by R. Similarly, it is E of t or E by R1. That's what I have written here. And we have an R1 resistor, then R2, C1, C2. This is what the output voltage V2. This is the reference point. Now we are going to consider two nodes whose node voltages are V1 and V2. Can see here. Now we have the circuitry for the node 1. This is an incoming current and R1, C1 and R2. Here I have written the current through these elements because I am going to apply the KCL at node 1. V1 by R1 plus C1 into dV1 by dt plus V1 minus V2 by R2. This is an outgoing current. The incoming current is E by R1. This is an equation 1. We have to take the Laplace transform. V1 is nothing but it is V1 of t. So V1 of t, if we take Laplace transform, it is V1 of s. R1 is constant. C into, when we find d by dt, it is s into V1 of s. V1 of s by R2 minus V2 of s by R2, E of t is nothing but a Laplace transform of E of t is nothing but E of s by R1. Now we are going to take V1 outside from these three terms, 1 by R1 SC1 1 by R2 minus V2 of s by R2, which is equal to E of s by R1. This is equation number 2. And here I am representing the node 2 and the associated connections. We don't have any current source here. We are going to apply the KCL at node 2. Incoming current is 0, whereas outgoing current is V2 minus V1 by R2. Current through the capacitor is C into dV by dt. So here it is C2, so C2 dV2 by dt. This is equation 3, and we have to take the Laplace transform. It is V2 of s by R2 minus V1 of s by R2 C2. When we find d by dt, it is s. V2 of s is equal to 0. Take V2 of s outside from these two elements, 1 by R2 plus SC2. I am moving this V1 of s by R2 right side, and we are going to solve it for V1 of s. V1 of s is nothing but V2 of s into this term. So after simplifying, we will get 1 plus SC2 into R2. This is equation number 4. We know that this is an equation number 2 and equation number 4. We are going to substitute this V1 in this particular equation. And we are going to take V2 outside from this term and this term, and we are cross multiplying these terms, and finally we will get 1 plus SC2R2, and from this term it is R1 plus R2 plus SC1R1 R2 minus R1 divided by R1 R2, which is equal to E of s by R1. And we are going to compute the transfer function, that is V2 of s by E of s. Just to rearrange these terms, we will get this equation. As a result, in this problem, we have derived the differential equations using the KCL, and we got a differential equations, one at node 1 and another at node 2. And the transfer function of this network is R2 divided by 1 plus SC2R2, R1 plus R2 plus SC1 R1 R2 minus R1. These are the references. Thank you.